Hi, good morning. You can get a start. Our distinguished guest, Professor Zhang, Professor Lin, President Professor Wai, and our Dean, Professor Liu, and colleagues and students. Good morning. So I'm Dr. Zhao and head of the Department of Physics. And today we are very happy, honored to have Professor Zhang from Taiwan Zhongyuan Christian University to come to our campus and pay a visit and give a distinguished lecture on quantum technology revolution. And next, let me invite our President, Professor Wei, to give a welcome speech and introduce our guest. Professor Wei,
Professor Zhang, Professor Lin, Jiming, my head, okay. Well, I am in your department, okay. I am, okay. Distinguished guests, esteemed colleagues, alumni, and students. Good morning, and welcome to Hong Kong Baptist University. On behalf of the university, I am delighted to welcome Professor Chang Ching Rui to our campus for giving this distinguished lecture. As a distinguished theoretical physicist and a leading figure in quantum technology, we are truly honored to have Professor Zhang here to speak to us today. Professor Zhang obtained his bachelor degree in physics from the National Taiwan University in 1979, and his PhD degree in physics from the University of California, San Diego in 1988. Next year, in 1989, he returned to his alma mater, where he held various leadership positions, including being the executive vice president and interim president of NTU. In 2022, Professor Zhang joined Zhongyuan Christian University as a director of the newly established Quantum Information Center and Fujitsu DAU Quantum Computing Center. Throughout his career, Professor Zhang had been a trailblazer in the study of structural and sub-nanosecond dynamics of micromagnetic materials. His numerous scientific contributions have enhanced our understanding of nucleation, spin dynamics, and thermal activation of, next page, such systems, as well as a spin transport in low-dimensional materials with industrial applications. In recent years, his research focus has shifted to the emerging field of quantum computing and quantum technology, a very hot field, a subject he will discuss with us today. With more than 280 published papers and more than 20 magnetic-related patents attributed to his name, Professor Zhang has received numerous accolades for his work, including the IEEE Nanotechnology Best Paper Award and the American Physical Society Outstanding Referee in 2019. Now, in addition to his research achievement, Professor Zhang has demonstrated exceptional leadership by serving as the president of both the Physical Society of Taiwan and the Taiwan Association of Magnetic Technology. Professor Zhang is a fellow of the APS, American Physical Society, and also the Institute of Electrical and Electronics Engineer, IEEE. As a visionary leader in this field, Professor Zhang has made significant contributions to the development of quantum computing in Taiwan. He has served as the director of the NTU IBM Quantum Computer Hub and the chair of Quantum Computer Promotion Office at the Ministry of Science and Technology, Taiwan. Professor Zhang also founded the Taiwan Association of Quantum Computer and Information Technologies, where he currently serves as the president. Today, Professor Zhang will share with us about the quantum technology revolution. The quantum world is largely different from the classical macroscope world, and the concepts developed to explain quantum phenomena, such as entanglement and uncertainty principles, have profoundly altered our understanding of the physical world, making a tremendous impact on science, technology, humanities, and philosophy over the past century. While previous electronic and information technologies have brought significant changes to the society, only a small amount of quantum science knowledge has been applied outside the laboratories. The emerging quantum technology is expected to rapidly propel the re-evolution of human civilization in the coming decades. Today's lecture will highlight the importance of this revolution, the potential impact of quantum computers, and the preparation which the industry and future quantum generation should undertake. Professor Zhang, we will all look forward to your enlightening lecture. No doubt that we will benefit from your insights into this new and exciting field. Thank you very much.
Thanks for the very great introduction for this talk. And I think you almost finished everything. And first, I want to thanks for the invitation, to have this chance to come to here and to share my view actually on the probably next decade. I think it is a really important period in the human history. We probably will spend 30 to 50 years to transform the classical Earth into the quantum Earth in the next 30 years. I hope I will convince you. Actually, I probably will introduce a little bit on the quantum superposition entanglement measurement and also the Hilbert space. That actually is a foundation actually for the second quantum revolution. And the people always ask actually a question like about will quantum technology replace the semiconductor technology? And also when I was in Taiwan, people asked me, Taiwan are so strong in the semiconductor industry. Also when quantum came out, where Taiwan, automatically become the strongest country in this technology. And I always tell them actually it's not necessary. The reason is that when Wright brother invented the air flight, and the car industry is already being very mature. And if you ask, will car industry people will automatically know how to make the flight? The answer is no. And also, if you ask the flight industry will really take place the car industry, the answer is also no. So actually, it's a similar situation right now. But however, I give a lot of, popular science talk actually in Taiwan for the last 2 years worldwide, probably more than 100 times already. Another question I always, give to the audience say that in the very beginning, for the people over 55, you should be happy to be retired. Don't worry about these things. But however, for the people under 20, it's no way for you to escape the quantum society. Actually, I think that the things will gradually move actually from the quantum breakthrough in certain field. Actually, the quantum supremacy was announced by the Google in 2019. And actually certain things already have certain demo the breakthrough. And gradually move to we call the quantum advantage in every field. Then finally we move the final stage we call the quantum ecosystem. And that actually every people will involve, no matter in which field you are inside. I think that even the quantum the philosophy and the linguistic, everything will change and affected by the quantum technology. So actually, I'll give you a short introduction. I think the engineer and programmer do not need to know much, but no time to ask when quantum technology will come. Just believe it, learn it, and use it. So I will give a certain, short introduction on the hardware and the algorithm and some application. Actually, right now, people believe the four major, application immediately on the quantum computation will be one in the material design, drug design, and the metropolitan system, large data control. And the last one actually is very interesting, is quantum financing. So because actually it's optimization problem, so also the quantum security, the cryptography actually will be changed also. Of course, you need to have the quantum AI, quantum deep learning. More broad view or grand view actually from the history, human history. Actually, we know when the human appear on this earth, only 50,000 years or 100,000 years. But the agriculture actually appeared about 12,000 years ago. And the modern science is less than 400. The Industrial Revolution actually is less than 300. Even though we are very, think we are live in a very, advanced technology society right now in the earth, but actually it's less than 300 years. And the Maxwell equation actually developed actually is less than 200 years. And the Boltzmann and the Boltzmann theory actually is so quite near. And the Planck the quantum theory actually the quantization of quantum concept actually less than 130 years is. So actually all the modern science actually is very close to our current stage. However, actually China actually when those modern science and noble technology was appear, actually they are all are within the Civil War. So actually when the Newton, the thermodynamic come, actually is Qing dynasty come into the China. And when Maxwell developed his, EM theory, actually is the 八国联军 actually go into China. And you see, actually we are always in the war. So we don't have time really study the science and actually take the effort on the technology development. So actually for the last 40 years, China indeed, did a great job. They catch up the last 400 years, the science and technology development. And if you take a look on this, it's an interesting statistic. As I say, actually agricultural technology came out, but the population actually inside the Earth only between 200 million and 300 million. They fluctuate all the time for thousands of years. The reason is that the Earth only can supply this number. When the population number over than 300, they must have a big war happen. So it's fluctuate. So actually the population increase on the Earth is only happen, even though you have a lot of, politicians and good philosophy, or even like Jesus and Muhammad appear, but they cannot increase the population on the Earth. The population on the Earth only increase when the modern science and the industrial revolution came. So the current science and technology did a lot of contribution to the Earth population. So last year, actually the end of last year, actually the population on the Earth actually increased from 300 million up to 8 billion. And will this number keep growing or saturate? Depends on how we proceed the new technology and develop the new science and new technology. And the quantum science actually is studied from Europe. This figure is very famous photo. And 29% attended this conference. They called the Solvay Conference in 1927. And 17 of them got the Nobel Prize. It's an amazing photo. Actually, this is the fifth Solvay Conference. The conclusion was made by Born and Heisenberg. And the Einstein proposed, actually challenged the quantum theory at this conference. He say he doesn't believe the God will throw the dice to create the universe. However, Born and Heisenberg made a conclusion, say, Einstein, we don't need extra theory for the quantum theory. It's already like this. We know everything. So actually, this photo actually, give a lot of contribution to the modern science. And so after this conference, Solvay conference, we how they say American, finally used the general relativity and the quantum theory to make the Manhattan Project, to produce the atomic bomb. The fat boy and the little boy drop into the Japan. And so, finish the World War II. And then they become the leading role in the war. So that also comes from the science contribution. But anyway, after World War II, the first computer was invented by UK in Manchester, only 48-bit. However, after that, and the Americans still invented the bipolar transistor and MOSFET. So actually make the classical bit actually become very fast. So they still keep the leading role in the technology invention and also control actually the whole world. 2018, actually people right now think this year is the first year of the second quantum revolution. Why is that? Because actually this year, in December, American passed a new act they call the National Quantum Initiative Act by Trump. And they ask all the public agents need to support the quantum study and the quantum technology. It's really enforced into the law. And in Vienna, last year, also December 1st, and I attend this meeting. They say the quantum flagship kickoff meeting. They have about 300 European, policymaker and the very advanced scientists to get together, say what the next step Europeans need to do. And Zeilinger was the Nobel laureate last year. He was actually the chief scientist for this meeting. I was impressed for his open speech. He said, quantum science was discovered by the European, but how come the quantum technology, good fruit, is all harvested by US, not the European? And he said, this century now actually is the second quantum revolution start. We Europeans should get together, work together, not only to kick out the quantum fracture. We need to form the quantum fleet to let the European to be strong again in this new coming century. But anyway, Japan also initiated the national project, Quantum Leap Program in Japan. So people believe actually 2018 is the first year for the second quantum revolution. And nowadays, actually, IBM already announced 433 qubit online. And National Taiwan University signed agreement with the IBM, so we can use this 433 qubit online. But brain to say, it's only for the proof of concept, the project you can do. It cannot solve the real problem now because the error is too huge. So actually, we signed agreement with the IBM actually on the 2018. So the function actually for the NTU IBM Hub is that first the research. We go through the IBM networking, we can get in touch with worldwide. And also education, we let the Taiwan user to study, the student, the professor. Then the third function actually is the promotion. We get in touch with the financial industry and the major industry inside Taiwan and give them public lecture and convince them this will be the future. And this actually is a report from the IBM. Right now, I think their university partner is more than this. When we joined in 2018, we are the 7th. Right now, actually, they are more than 16. And this industrial major partner, this is minor partner. What major and minor means, how much money you pay. And right now, it's more than 500,000 registered user. And the active user, which means used very actively, is more than 15,000. So actually, the Moore's law, actually, everybody know it sooner or later will be saturated. Because actually, they have the 2 to the nth power on the scaling down. And the reason why quantum came out, the people are excited because of Neven. There is a chief scientist for the Google. He mentioned actually the quantum can have the double power of the exponential law. The first one comes from similar from the hardware. Actually, the scaling down the property will give you 2 to the nth power. The second one is the entanglement from the qubit. Actually, this comes from the Hilbert space qubit, another power. So he claims 2 to the n, and we really follow this one actually recently. The first one, actually, people pay attention because of the Google announced this paper in Nature. 2019, Google used 53 qubit. For 53, if you make an estimation, it's around 10 to the 16 power, the classical bit. That's equivalent. So actually, he used the 53 qubit. He calculated one very specific random pattern. And they estimate use the Summit. Summit is the most advanced the classical computer at that time. Every second they can calculate 10 to the 17 flops. So they can actually in that paper say use 53 qubit. You can use 200 seconds for a special sample. It's a random pattern. And that will need Summit to take 10,000 years to finish. So they claim, they demo the quantum supremacy. They can do something classical computer never can do. So actually, that's the first time announced the quantum supremacy. Actually, the quantum computer, the calculation speed is not a major issue. The size is a major issue. You see, 53 qubit is equivalent to the 10 to the 16 power, the classical bit. If you have 270 qubit, it's around 10 to the 81 power of the classical bit. Those classical bits occupy the physical space. So if you take the cube and take the cubic root, so one side will be 10 to the 27. So if any classical bit use the current, even the current narrow technology cannot do, one narrow technology. So each side will be 10 to the 27 minus 9. So the lateral side will be 10 to the 18 meter. And this classical computer is larger than the Milky Way, cannot put on Earth. However, for the quantum computer, 217 qubit is equivalent to this. So actually, it's not only the calculation speed, it's really the physical capacity and the physical side. And after Google did this, actually Pan Jianwei, Jiu Zhang, they demo another things, use the photonic things to demo that actually they can use 200 things to carry out the computation. That actually, they say, you see 200 seconds actually for the Summit for 1 million years. However, Jiu Zhang 1 second, Google need to take the 10 to 10 seconds. So they say the photonic quantum computer they demo even faster than the Google quantum computer. However, these two things is very different because this is a quantum machine. It's not programmable. And Google's the quantum computer is a programmable machine. This one is they only can do one, fixed duty, and the very complicated optical role need to be studied. However, they still demo. It's quite possible to increase the computation power, even much faster than Google can. The first person emphasize the quantum computation important actually is Ma Yun. In 2018, in his company Yunqi Dahui, he mentioned about they were for Alibaba 2023, they were everywhere they were use quantum computation. And they try to invest $50 billion on this study. However, right now it's 2023. I think they didn't achieve their goal. But anyway, he had the ambitious and vision to claim on 2018. It's non-trivial. And as I say, Trump passed the National Quantum Initiative Act on 2018. 2019, actually, he formed the Quantum Technology Promotion Committee in his office. 21 person was the committee member. And why is try to push this one so fast? Because Nature in 2019 published one statistic. They claim the quantum pattern inside US, China already lead every country. So American cannot afford to lose this game. So they need to push very hard. As you can see, this color actually is the pattern for quantum communication. And then this color actually for the quantum computation. And this one for the other application. Major is quantum sensor. So you can see from here, US is inferior to China in quantum communication, but much advanced in quantum computing. From this static, Nature actually published this one. And President Xi, he had a special meeting actually on the 2020 in 北戴河, 中央政治局工作会. He invited the vice president of the Tsinghua University, Guo Xikun, to give a presentation, 30 minutes presentation on that meeting. And after that, he announced, all the leaders need to understand what is the future, what is the quantum technology. All the leaders. And so it's very interesting. Why they are so serious on this? Because a quantum computer, we will see, is just like a spear. And the quantum communication is like a shield. China actually is very advanced on quantum communication. They can protect themselves. Don't let other people know what they are doing. However, the quantum computing is like an attacking weapon. They can attack other people. So it's just like a spear. And the spear and the shield, they need to confront in the sooner or later. And the quantum sensor is like a more advanced sensor. And all together, three things together, I think in the future will form quantum IoT, much advanced than the current IoT. Very sensitive from the quantum sensor, very secure from the quantum communication. And also the connectivity is huge from the entanglement. Then the computation time is very fast and from the quantum computation. I think it's definitely the future. And this is another interesting, just published actually April 23rd, this year. It's McKinsey's, statistic. If you see this one, it's inconsistent from the Nature published the pattern in 2019. If you take a look, right now, US emphasize everything China is lead already. You see, this is a pattern, statistic pattern from 200 to 22. And the China quantum technology pattern percentage compared to worldwide is count about 50.3. And the quantum computation 50.8. Quantum communication 43.2. And the quantum sensor is 56.6. But no matter which field, all are leading role, worldwide. This is just published actually by McKinsey. I'm not so sure. Actually, I think quantum computation should still, US the leading role. But anyway, this book actually was published 2 weeks after President Xi made the announcement on 2020. And he say actually, 各级党委政府重要干部都需要学习新式掌握新动态. Anyway, so 人民日报 published this book actually. Actually, I also wrote a book, actually published on Beijing this January. And it turned out to be actually, it's quite recognized, very, very, very good book, 量子大趋势. Inside the book, actually, I divided the period of quantum technology by 5 periods. Actually, they started from 1981. It's the Feynman. Feynman actually at that time, he proposed we need to have the quantum machine, understand this universe. Without the quantum machine, you cannot understand this universe because actually all the material, they have the quantum superposition and quantum entanglement inside. You cannot use a digital computer to simulate the quantum universe. You need to have a quantum machine to simulate quantum universe. So actually people started from this. Right now, I think is the proof of concept, Nisky stage. Probably people is right now is asking, when will be the year to quantum computer? If you are old enough, you must learn this terminology called Y2K, year to 2000. And the people all are afraid the classical computer will fail. Right now, nobody care about Y2K. Everybody asks, when is the Y2Q, year to quantum computer? And the common sensor actually is consensus is around 2030. It's around 2030. Will be the year to quantum computer. Actually, my book, I was surprised. When I published after 2 weeks, 长安街读书会 recommend 的各级干部应该要念。That actually very surprised me. So I think Communist Party actually really studied a lot of things on the new book, new technology. The modern science actually, as I say, appear on the earth for only 400 years. Modern technology less than 300 years. Due to the various historical reasons, China always been struggling to catch up. That actually, we didn't involve in the developing stage. However, right now, the quantum technology create a new emergence of generation Q generation. And that gives China first opportunities to start on the same starting line. That actually is why China spent a lot of effort on this new technology. 中国有史以来从来没有这个机会跟世界在同一个科技起跑线起跑。这个是 It's actually you never imagined before. So actually, the performance right now, actually the performance in younger generation in China in the emerging quantum technology already entered the world leading role. And the quantum technology is by no means a short-term competition between countries. It should be a long-term collective competition between humans and nature. In the environment of stronger global competition, how to build a technology for the 800铁骑，这是邱成同讲的话，我用在这里啊。Actually, 等一下，我will see the ST Yao, the academician ST Yao, he mentioned how we should create the 汉唐光辉 to have the 科技800铁骑。And actually, right now, actually is we call the post-Silicon Valley era, and how to get the national science and technology energy to carry out new type of invisible technology of the second quantum technology revolution. That actually the quantum valley will be the inevitable mission for the new generation of China. 这个邱仁龙讲过一句话，他在清华未来10年要训练科技800铁骑，重建汉唐光辉。做得到做不到不知道。Actually, this was published by China Statistics. It's very interesting. They recently published. They admit they invest from 2018 to 26.3 billion on quantum technology, and U.S. 5 billion. However, U.S. estimation for China is that they invest more than 15 billion. That other number is consistent. Only how much China invested is different. U.S. claim actually China already invest 15 billion, and China admit they only invest 60 point. But no matter which digit, it's a huge number. It's definitely is already a huge number. Why they are so interesting on this? Because no single country afford to lose. They claim right now, the quantum technology is just like a Manhattan Project. It's a narrow Manhattan Project. If you lose your, your control. For China, actually, also for the other country, new emerging country, it's a new chance for them. They can bypass the semiconductor, computation. It's a new track actually for all countries. If you see this movie, Ants and the Wasp, 2018 the most popular science fiction movie. It's very interesting. They already have a dialogue inside there. The bad guy called Sonny Birch, the leading actress called Hope Van Dam. The Sonny Birch actually tried to get the miniature machine. He say this: "You think that I don't know what you have been building with all of this quantum technology, and you can forget nanotechnology, forget artificial intelligence, forget cryptocurrency. Quantum energy is the future. It is next gold rush. I want in 2018, the movie is on, and the screenplay was written 2016. The Hollywood screenplay announced at that time. You don't need to worry about other things. But actually 2016, we just probably started nanotechnology, artificial intelligence, and also cryptocurrency. However, Hollywood screenplay writer tell you the future is quantum technology. This is also a figure comes from US. Semiconductor right now, the production industry mainly actually in Asia. However, it's usually quantum industry mainly is in US and Europe. Only very little in China, in Asia. So you know what is the future, what is the past. And Biden actually claimed their scientific policy need to, they call the small yard high fence, which means for the very competitive the technology, you need to don't let the technology go outside. You need to build the high fence, and that actually is majorly is point to the quantum technology. Okay, so but the quantum technology is non-trivial. The quantum knowledge is really non-trivial. When I was physics major, I learned that actually probably start from the sophomore. It's very subtle for me. I cannot understand in the very beginning. But later on, I used the mathematical tool, and the practice led me to understand. So actually, if you want to know the quantum technology, even though there are quantum gold rush, you need knowledge. You need to study and find a teacher. This actually is a cartoon say, if you only know water, you don't know H2O is also water. When you feel thirsty, you will go a long way to find the water. If your knowledge is broad, then it can short your way. However, you need to find the right teacher in the right book to read. Otherwise, if you confuse H2O2, it's also water. you will go to die much sooner than don't read any book. This is the current stage, actually, for the quantum computer and the quantum inspired machine. The outside, the large circle, actually is we call the universal quantum computer. That actually is a programmer quantum computer. We use a gate operator to operate the quantum computer. It's just like the programming, we can do that right now. All the major companies actually are involved. And China actually was in Hefei, Benyuan Liangzi. They are doing very good, frankly to say. Other company, majorly actually is from US and Japan. And the Foxconn Crane, they were involved. And the second circle actually is quantum analog simulator. It's just like Jiu Zhang, I just mentioned Pan Jianwei. They only can do certain specific function, but still use the quantum entanglement and superposition. And this actually mainly actually from Japan and Canada. The inside circle is very interesting things. It's current semiconductor technology to simulate the quantum behavior. So we call the quantum inspired machine. And this one actually is majorly in France and Japan. And for China, actually, they have two companies doing the educational purpose quantum computer. One is in SpinQ, the other is in Hefei Guoyi Liangzi. SpinQ actually, two founders actually the day before just have dinner with me and Professor Lin together. They actually in Hong Kong. And they are building the room temperature 2-qubit quantum computer. And this actually is the three company 本源电子、本源量子、博弈量子 and 郭顿量子。The three founders, they call the China Quantum GDP, right? The 郭光灿、杜江峰、潘建伟. Their last name is just like GDP. So like these three person actually is quantum GDP. And all three company actually in Hefei. They also have a lot of startup company. The SpinQ actually is the two founder, one from graduate from Harvard and the other from MIT. They joined together to start up this company actually 4 years ago in Shenzhen. Both and Q actually two students from Stanford University. They start up this company actually in Beijing. And Turing actually is from Cambridge. And they start the company actually in Shanghai. And Kudo actually they graduate from the Chinese academic. And they also started this in Beijing. So quite a lot of young people actually is very aggressive right now start up the new company. It's more or less like Taiwan when Professor Lin was start the semiconductor industry in Taiwan. It's very interesting. And this is VC worldwide. There is only one quantum nation. They are all focused on the quantum technology. Other the VC actually only part of their investment project is on the quantum technology. However, so people sometimes ask, is there any new company for the quantum technology? Frank to say it's already a lot worldwide. This is 4 companies right now for the quantum technology already been IPO in the Nasdaq and D-Wave actually is in the what is American stock market? Dow Jones and the Nasdaq. They dropped very significant last year. However, last night I was very surprised. I don't know what's happening. I still try to understand. D-Wave bounced back last night to increase about more than 100%. They bounced back. I don't know what's happened last night. But anyway, for the last year, they dropped very significant. And this is IBM roadmap. IBM CRAN, this year, they will invented frictionless quantum computer. Next year, they will start to the error correction. Then the 2025 will combine high-performance computer and quantum computer together. Hybrid system will come out. The friction means what? Because right now the quantum computer is hard to use. You need to expert to use. Like CRAN, after this year, the regular person can start to use quantum computer. However, this year actually, last year, the end of last year, they announced 433 qubit. This year, they say the end of this year, they were over 1,000. And the 2024 or 2025, like CRAN, they were more than 1 million qubit. That's amazing progress. If they really can keep this pace, I think 2030 definitely, the year 2 quantum computer will appear. IBM, the goal. Sorry, I put the Chinese character in here, but I will explain a little bit. Actually, the goal actually for the end of this year will be they will deliver more than 1,000 qubit. And the second thing is not only in the hardware, they also try to modularize the quantum chip, and then use the quantum communication or classical communication to link those kind of the module together. So that one can be easily scaled up instead of only increase the qubit number. The third thing is that they try to develop the quantum software. And for 2025, all the machine learning and optimization and will be in really practice. They also start to do the software development now. So Levin, the Google chief scientist, he say, It looked like nothing is happening, nothing is happening. Then, oops, suddenly we are in a different world. That's what we were experiencing here. And the things change as they never always do. This photo actually is the 1900 in New York Fifth Avenue, the most, traffic jams, avenue. All are wagon, only one motor cargo, photo motor cargo. And the people don't believe photo motor car will replace the wagon at that time. But only 13 years later, still on the New York Fifth Avenue, all become photo motor car. Only one wagon stay on the side. So right now, we probably, around the transition period. Okay, so that actually is the history. I will give you 5 minutes for the quantum computer explanation. Actually, the quantum computer, the advance comes from the three things together: physics, math, and the computer science. Not only from the physics. And also the physical, basic concept, the superposition, entanglement, measurement, Hilbert space. I hope I can give you a brief idea what is this. And then what quantum computer is doing with the quantum circuit and quantum gate, and what we can do right now. Classical bit is like a coin. The head is 0, the tail is 1. Is a fixed state. However, quantum qubit actually is superposition of 0 and 1. If you consider a sphere, the north pole and the south pole is the classical bit. If you do the superposition, the whole sphere surface actually is the superposition of 0 and 1 together. So you can describe the whole things, the sphere surface, all at once. But for the qubit, you only can describe the north pole and south pole. So if you want to think, visualize what is that, you can consider the superposition is just like a rotating coin. In any time, they are the superposition of the tail and the head. So only when you take a measurement, you take a quantum measurement, you stop the rotating. They will decide it's head or tail. So the measurement decides the final state in classical way. However, during the transition states, they are always in the superposition state. But most subtle issue actually, it will be if two qubits entangle to each other, what will happen? And we all know the result, actually. I will explain why is that. But we all know the result is that no matter the other one go to where, you always know their associated status, entangled status. That actually is the entangled means. Actually, the quantum computer is in certain ways that in math and the physics we trust, we use the Hilbert space actually to solve the problem. So actually, the entanglement is more or less like the 有个中国歌叫做我你中有你，你中有我 They really mix together. So the coherent time, before you get married, the male is 1, female is 0. So when they get together, they become entangled state. However, if you fight to each other, it's decoherent. So they will get divorced. But we want to have the long coherent time. Actually, they can, go to the end of their life together. Right now, actually, the quantum computer qubit entangled state, we only can maintain less than millisecond. However, for the past 10 years, it already increased a lot from nanosecond to millisecond. So within the millisecond coherent time, we need to finish everything to get the neutrons and everything done. That before they get married. So we need to do the quantum gate operation very fast before they lost their coherent time. If the entangled state can maintain more than a second, I think the universal quantum computer can appear. But right now, it's still far away to go. So actually, the quantum measurement actually is actually one example to say this actually is the Young's double slit, interference. As you know, actually, if you have a light source and one single slit on the screen, you will see the pattern like this. If you move your slit to here, then you will see the pattern like this. This is the normal way you see. If you have two slits, in high school, you learn this. They will have an interference pattern. We call the Young's modular interference pattern. However, for the quantum measurement, it's very interesting. They say actually, if you take a measurement on the screen, you see the pattern like this. But if you took your measurement, you want to see which slit they are going through, then you will see the pattern like this. So actually, the quantum measure determine the result. This is not the classical way to figure out. So the quantum actually have quite a unique property, depends on the quantum measurement. But frankly to say, this in the classical world, you also experience on that. When you are in high school, during the 自习课, without the teacher, everybody were walking around. But with the teacher, everybody sit there and study very hard. So actually the observation and the measurement will affect outcome. But anyway, what is entanglement? Classical and the quantum, actually the result definitely will be the same. Such as if we have the one color, A color have the 5 ball, and the B color also have 5 ball. I put the 4 of the A color into one ball, and 2 of the B color into another ball, and put into the Hong Kong. The other box sent to Shenzhen. If I open the box, I see the result is 4 of the A color, 2 of the B color. And what will be the box contents actually inside the Shenzhen? Definitely you will give your answer is 3 of the B color and 1 of the A color. This result, no matter it's from quantum or classical, it's the same. Otherwise, we cannot survive. So the result is the same. However, how do you say that? The process is different view from quantum and classical. Einstein cannot figure out the philosophy of entanglement. So he think, even though you don't know, we don't know what is the inside the content. However, someone should know. So someone already know and put it inside. But for the quantum, actually, the boss say, nobody know. Before you open the box, the possibility inside this box can be from 0 to 10, all the possible combination. And the Einstein say, no, it's already been fixed. That actually is the only difference between that. So the quantum theory actually tell you, only when you open the box, you know the result. Before you open, nobody knows. But Einstein, because influenced by the Newton deterministic theory, so he believed must be someone already know that. Actually, that's the only difference. But right now, we use the science, experiment to verify quantum theory is right. And another classical way in the micro world. Actually, which you can try to use this to understand what is the quantum probability. 很多人都买刮刮乐 scratch. When you scratch, your number came out. Before you scratch, the number is fixed. Or it's just like lava. Only after you scratch, the number fixed. Which one you believe? Most of the people in the classical way must be believe actually it's already been printed there. But actually in the quantum, only after you scratch it out, the number is finally determined. Actually, this is Schrödinger case meaning. That's actually a different philosophy. However, in the science and the technology, we really manipulate those things right now. And in a very SOP measure. So actually the quantum gate, this is quantum classical computer. You have electric signal inside, 10, 10, 10. Then you do in certain gate operation, you get output, still 10, 10, some certain arrangement. And the quantum computer is different. They use the gate operation because they want to the current engineering easy to adapt. However, the concept is different. The concept, you create the quantum circuit. Actually, we call the quantum oracle. We create, and this actually is the way you build your function and you prepare the initial condition. Then you measure it. Then you got the final result. You didn't calculate. You create the measure tool, then take a measurement. You don't do any calculation. So usually the magnetic phone in the classical computer we write in this way. A operates on X, got Y, and this is quantum state, quantum state. It's different approach. Also, but the philosophy. So actually, for the quantum computer, just like a huge waterfall. It's not like the classical computer. They drop actually one in series. They just in parallel, and the huge quantum. The only things what you need to take effort is that you make the vessel. It's the tool. It's a quantum oracle. You try to solve the problem. You make a special quantum oracle. That actually took your time to use the gate operation to implement quantum circuit. So the qubit right now actually is the physics side. We have the solid state qubit, MNR qubit, photonic qubit, atom qubit. However, physicists only know how to do this. But to make a quantum computer is a system integration problem. So sometime when I was in Taiwan, I say, when Taiwan quantum technology can appear, it's only when physicists realize this is not a problem for physicists. And also the outside the physics curriculum people realize this is their duty to fabricate the things. Otherwise, it will never appear. Actually, right now, the cryogenic, they call is a new field. It's a cryogenic, it's CMOS and others. Why is important? This side actually is for physicists, because actually the qubit is within the 5 to 10 millikelvin. And however, the control system, the circuit design, they call the circuitry quantum electrodynamic, is a CQED. This is a new field, cryogenic. You need to design the circuitry can operate within 4K. And this is a conventional semiconductor. They low into the 77K. And all the new emerging technology are in here and here. And this actually is the room temperature quantum computer made by Hefei. This is actually room temperature quantum computer, teaching quantum computer made by Shenzhen. And in the sooner, they try to, just like IBM proposed, they try to use the quantum communication to connect the quantum chip. If this can be success, then I think the scale-up procedure will go in very fast. So actually, the leading quantum computer hardware candidate, they have two. One is trapped atom ion, trapped ion. The other is superconducting circuitry. This is aluminum, and use the LC capacitor and the inductor. They make a electric resonance to make the artificial qubit. So we call it artificial atom. Because they're artificial atom, so it's engineering problem. So it's easy for engineering to control and to scale it up. And this actually is used the periodic table. You use a second row, 皮美盖斯贝雷. They kick up one electron, and they become hydro-like, structure. Then use they ionize the atom, so they can use the external electric field and the magnetic field to control them. And they use the ionize this second row, and they use it as a nature atom as a qubit. That's the two major leading technology right now. And 2025, a lot of companies already announced their target. Actually, photon, they want to over 1 million. And the trap ion, the Beijing startup company, more than 200. Superconductor, IBM, more than 4,000. And the core atom, more than 1,000. And the other things. Actually, a lot of competing technology right now. So the final things is the software and the control things. You use the program gate, quantum gate to control the hardware. And those basic gate operation for the single qubit use the rotation along the XYZ and the Hadamard gate, also phase shift. And for multiple qubit, the main control actually is CNOT gate. The Toffoli gate also is a control 3 qubit. But anyway, you can find out the fully explanation for this actually on any introduction book. But with this, we can do a lot of programming things to do the things. And you need a quantum algorithm. With a quantum machine and the quantum basic operation, then you need a quantum algorithm. They have one very famous quantum algorithm. One is a Shor algorithm. The other is, the global algorithm. Shor algorithm, people is very easy to factorize the things number, so they can how do they say that? They can attack the cryptography, because right now the cryptography in finance we use the RSA, cryptographic technology. And that actually is you need to have two-prong number, and the Shor algorithm can easily to solve the problem. And I will give a little idea what is a global searching algorithm in quantum way. Actually, in the conventional thing, you do everything every day. Searching is your major issue. Take away from the dinner, lunchtime, and your bedtime. The most things trouble you every day is to search the things. You search things abstract in your mind, and the search in your office, in your home. So the classic way to search is NP-hard problem. Actually, the mouse try to find the cheesecake in here. They need to try and error. No other way. So when the exit number become huge, this become NP-hard problem. However, this is because you are classical particle thinking way. If they have the quantum K try to catch the Schrödinger K try to catch the classical mouse. So what he will do? He will behave like a wave. Because in the matter wave, they are just like a wave. So actually the result, the answer is there. How to use the quantum algorithm to do the interference, construct the interference, let this result go back to the classical world to let us know. And the global already write the standard form way for you. They call global searching algorithm. So that's the reason why they are so fast. They don't do the calculation and the finding. So with this new technology and new algorithm, we can solve the classical things, such as the NP-hard problem in the classical machine. We also can use the quantum machine to solve some problem we never figured out before. It's a quantum natural problem, quantum chemistry, quantum thermodynamic, quantum image, quantum sensor. So people believe in the future drugstore, you give like one drop of your blood, then can identify your future, and also find the best medicine, special personalized design for you with the quantum computer, make you become long life and live forever. And this is a metropolitan problem. This is Beijing City. Actually, Volkswagen collaborate with Beijing City. Toyota collaborate with Tokyo. And if you see, you had 10 to the 6th power car within 10 to the 3rd street, your arrangement will be 10 to the 3rd to 10 to the 8th. And it's impossible for classical computer to figure out which is the best for your car to go in. So how do you say that? So the metropolitan problem become very sophisticated. And however, use a quantum computer from Beijing City to the Beijing airport. If you don't allow them to do the things, they will all jam together. But with a quantum computer, they will be easy to access to the airport. And this actually is a quantum finance. Long time ago, we have the abacus actually for the finance. Supercomputer came out. We have the quantitative finance. Right now, actually, quantum finance. So actually, quantum computer in 2019, just like a PC in 1968. Also AI. And also we can use the quantum entanglement to do the quantum communication. Actually, quantum communication is no different with the classical ancient China. You need three, layer. One is the networking, the other is, stamp envelope. The third one is encrypt text. And right now, the digital age is still, you need network, you need the key, then you need the encrypt text. They just use the electric signal to send the message. The idea is the same, the tool change. In the future, actually, quantum communication, they can a little bit combine the last two stages. Actually, they call the quantum directive communication. They use the single channel to deliver the key and text together, but they still need hardware, networking. And this actually is Argonne try to build the quantum communication channel between Chicago and the Argonne lab. Right now, 83 kilometers. However, China already built more than 2,000 kilometers from Beijing to Shanghai. And they also had the communication from Mozihao to the Earth, the satellite to the Earth. And in the future, that their grand plan, they try to build the quantum communication network waiting everywhere. Even put in Taiwan and Hainan Dao. Here is Hong Kong, must be. And also quantum radar, quantum sensor. I only propose the quantum radar. Actually, quantum sensor to make your all the sense, become more sensitive than ever. And this one actually is quantum radar. The U.S. have the 隐形飞机, stealthy air flight. And they always claim China already developed quantum radar. The conventional radar, they send a microwave up to the flight, then come back to receive. However, the 隐形飞机, stealthy air flight, actually, they use a shape design and the absorption material, coating material on the surface. So the cross-section actually become less than a buck. So the classical microwave cannot detect them. However, the entanglement property, you can send one entangled photon or microwave up to the air, the other directly sent to the receiver. So this one came out, they compare the entangled signal together. They become very sensitive. So actually, the 隐形飞机 become useless. And that one actually is also developed. You can also, people right now identify actually the heart actually probably is not only a pumping machine. They find some evidence that they might entangle with the brain. And this actually recently also have the NRI report. And this actually is very interesting statistic is that the end of last year in China, all the quantum technology, startup company and the major companies distribution like this. And the early this year, they announced a new figure. Only in Beijing already have seven new startup company. And 上中下游 actually all are already quite a lot. And this actually news, 半个高铁车厢都是去合肥的 VC 在投资这个。合肥有一条亮的 Quantum Boulevard. Actually, right now in Hefei, 霞飞大道 already have the quantum computer industrial park, quantum communication industrial park, and the quantum sensor industrial park. So actually in the physics, actually the mechanical and thermodynamic, after the industrial revolution, we have the college of engineering because we need engineer. For the EM wave and optical nanotechnology, from the physics and become the real industry, we need an engineer. So we have the College of Electrical Engineer, College of Information Science, and the College of Material. Right now, we also need a lot of engineers. Only physicists and scientists cannot build the industry. So gradually worldwide came out the College of Quantum Technology and the Quantum Information now is over here. And a lot of people right now try to, because actually quantum science, quantum knowledge is really sophisticated. So if you teach only from the university, it's too late. So right now, Americans try to propose, you need to teach from the age 3. The story, your mother tell you better side story. And then you have the common sense, when you grow up. So actually, they really have a lot of things right now, such as the IBM invented the app, quantum app, and also the ball game, entangling. And in here, they say the American they say you need to study since age 3. And they really have the story book right now, the quantum physics for baby, and also qubit for the Kuiper tree. Why spend your effort to learn things like the Kuiper tree? Qubit is your future career. Because the Kuiper tree actually is endangered species in Eastern Africa. Yes. So why spend your effort? And this is, Nian Shu, the founder, his new baby, you know what he read for him? Quantum physics for baby. So this disappearing industry, when I was in my primary school or junior high school, I need to learn abacus. And also I was required to charting with the dark beer pen. But when I was in my undergraduate, all those industries disappeared. I spent a lot of time to learn that. Suddenly they disappear. And nowadays, actually, a lot of things is in the endangered species. Such as, second language, second foreign language and programming, I think will be replaced by the ChatGPT. You spend a lot of time to learn that. Maybe after 10 years, just like when I was young to learn the abacus. It's useless. So actually, Americans really spend a lot of time for the quantum game. Did you play the tic-tac-toe? Did you know they have the quantum tic-tac-toe now? Very interesting and very, very, how do you say it? For me, I think interesting. However, they really embedded, quantum tic-tac-toe really embedded entanglement, superposition, and the measurement idea over there. They ask you, don't know the knowledge, but learn from game. That is your common sense. So actually, Quantum Tic-Tac, they have a startup company. They call the Quantum Tic-Tac company. And also, the science fiction movie. In Taiwan, actually right now, we have a director right now, supported by Hong Hai Company. They have the Quantum Cibala. Because you 3 dice altogether, the maximum number is 18. So quantum 18 is use the size dice to see the things. And also the 3 body, right now is very popular in China. The series, and they mention about entanglement. The final actually is education. Without the enough well-educated people familiar with the quantum common sense, the quantum ecosystem of quantum errors will never appear. So actually, the first undergraduate established is UNSW, 2021. They recruit the undergraduate. And the second actually is that Wurzburg, and then actually the Chicago area, actually University of Chicago. China, actually the governor, Ministry of Education, announced on 2021, is allow 本科生 in every university can set up. And Taiwan, actually I propose in Zhongyuan, we also set up the undergraduate program since this year. And Guo Guoping actually is the how do you say that? The chief scientist for the Benyuan. He recently suggested the minister officer should, in the undergraduate and the high school and the primary school, to set up the education system. Because actually, I think 这个他讲的是我对的。他说量子计算不是一代人能完成的，你必须要开始教育。然后让形成一代接一代的持续奋斗。And nowadays, 2020中科大成立量子本科班，2021长江大学成立，2022北理工、西南大学、安徽大学、湖北大学、郑州轻工刚刚获得教育部同意。然后这个国防科大和信息工程大学也被同意，现在正式本科生招生的。被核准的就是这些学校，然后再下来就清华大学的交叉信息学院成立了，所以目前是 It's just emerging in the undergraduate education. And some people say, why you need a special quantum engineering, undergraduate course? You only need to invite the physics to train in that. However, if you really take a look, quantum communication, quantum computer, and the quantum sensor, it's impossible for physics to build that. It's an integration system. You need a lot of interdisciplinary training, and that one can only be trained on the new emerging college. OK， 最后几页啊，这个是最近出来的资料 ，McKenzie 给的资料。他这些资料里面把中国都讲到全世界第一。I don't know why. Actually, their report say quantum technology中 China is the leading one. If you see, quantum technology, European and China publish most of the paper. This is percentage-wise. China published 22%, European published 22%, United States only 10%. And last actually is a research institute. They have the publication on the major research. China had 29% on publication. And this actually is an impact, high impact paper. And the European become larger. This is a master degree. Actually, right now, all the master degree research institute right now worldwide have so many. And the undergraduate, graduate program, right now, the whole world already have less. So actually, the future of quantum technology actually is hardware and software design. You need knowledge of the hybrid of quantum and the classical technology. There are new industry coming out, new resources you need to invest, and also you need to train the new talent and its new direction. They definitely need to use the classical and semiconductor knowledge, but they need to also to have embedded the new concept. So actually, this speaker comes from Zheng Bei. I take advantage of her contribution. I think actually, if you know the physics, we have the Stern galaxy experiment, and in 1920 and 21, the internal degree of freedom for the electron. When they go through the magnetic field, they will go bending up for the spin up, bending down for the spin down. So she can, for the human in the future, you go through the ChatGPT and the quantum technology. People know how to use the ChatGPT and quantum technology, become Superman. And didn't know how to use that, become idiot. So in the future, it's become a sophisticated. But however, right now it's really science and the technology erupt period. After the outbreak of new corona pneumonia and the IBM 21 they saw out the first quantum computer. Right now, IBM already sold out for 6 quantum computers worldwide. And 21 is sold out the first one. And also 21 is the metaverse. And 2021 is the low Earth orbital satellite. And the 2022 is ARMS ChatGPT. We don't know what the 2023 is what, 2024 is what. However, we definitely know 20 will be the year for room temperature computer. 20 will be the year for future pharmacy. And the 2015, probably people expect where nuclear fusion will come out. So in the next 30 to 5 years, if you think right now is already in a very advanced technology environment, but for 30 years to 50 years, things will advance much faster and much more than you thought. So actually, a very famous futurist called Ray Kurzweil, he predicted more than 180 things, and 90% was really realized after his prediction. He said 2027, human can model the brain. And 2030, AI have the ability of thinking like a human. 2045 will be brain-computer integration. We will see. Is that a success or not? However, with the quantum technology assist, I think those things definitely will be achieve sooner or later. 2019, Forbes have an article mentioned about quantum USA versus quantum China, the world's most important technology race. It's very interesting, the mention here. We are now witnessing a quantum battle, and that will be fought in research lab. We use the research lab to replace the battlefield. And we use the human brain instead of gun, scientists instead of soldier. However, if United States lose, the long-term effect will be chilling. I think right now, after 4 years have already gone, it's not only the scientists. You need the platoon that is engineer. Quantum, and without the quantum engineer, cannot fabricate anything real. Scientists, find out the things already exist in this universe. But engineer use the theory to invent the things never exist in this earth. So actually right now is the engineer, you need a real battle came out. So now it's not just scientists who are replacing soldiers. Quantum engineers are the real army for long-term competition. It's ongoing narrow Manhattan project. So let me conclude. 量子世纪到了，你不要怀疑了，相信它，学习它，使用它。这个希望今天的演讲让大家有这个感觉，你要花时间。这个 Chief Scientist Niven 最近讲过很多话。He mentioned it's not a one company versus another, but rather humankind versus nature, or humankind with nature. Only with this one, we Earth can proceed and transform to the quantum Earth, and the people can live in a much better and advanced environment in the future. So I hope I can convince you with this short time. The quantum verse is the future. Thank you.